So equation 7 represents the AC component of the output current of the inductor filter. Now the total current flowing through load, the total current flowing through the load will be the sum of the total current through the load will be the sum of DC current plus the sum of AC current, the sum of DC and AC current. Now DC current is 2 Vm over 4 RL, and the AC current is 4 Vm cos 2 omega t divided by 3 pi into RL square plus XL square. Now this is the DC current and this is the AC current. Now ripple factor is defined as ripple factor is defined as ripple factor can be defined as gamma by gamma, which is the root mean square current over the DC current IDC. Now this is the root mean square value or the maximum value of current. The maximum value of current, AC current, is this one. So IRMS, I will write it here, 4 Vm over 3 pi into RL square plus XL square. And DC current is almost already given there. It is what we call it. It is here represented by this value. IDC. IDC is given by this equation number 3. So if we put it in this ripple factor, the ripple factor will come out to be gamma, which is equal to, we have this 4 Vm over 3 pi into square root of RL square plus XL square over square root 2. Sorry, this is the peak value, I peak. This is the peak value, while the RMS value will be I peak divided by square root 2. So this is given here. So the peak value will be this one, 4 Vm over 3 pi RL square plus XL square root divided by this factor 2 over the DC current, which is 2 Vm over pi RL. Now this can be written as 2 over 3 into square root 2, and we have RL. This pi cancel with, now this Vm cancel with this Vm, and this 2 cancel with this 2, 4, so we have 2. So if we rearrange it, we get RL over RL square plus XL square root. From the denominator I will take 2 RL over 3 into square root 2. I will take RL square common, so it will be RL to 1 plus XL square over RL square whole 1 over 2. So this RL will cancel with this RL. So we have 2 over 3 into square root 2 into 1 over 1 plus XL value is XL value we already calculated, it's 2 omega L. So XL square will be 4 omega square L square over RL square whole 1 over 2. Now we use inductor with large inductance, so it means that this 4 omega square L square will be much greater than this RL square. This 4 omega square L square over RL square will be much greater than 1. So this implies that the 1 here which appear here, 1 can be ignored because this value is much greater. If we add 1 or if we subtract 1, that it doesn't change too much. So our ripple factor will be equal to 2 over 3 into square root 2, and here we have 4 omega square L square over RL square, so it will left with 2 omega L over RL if we keep it outside of the square root. Our ripple factor is equal to 2 cancel with 2, so we have RL over 3 into square root 2 omega L. This is equation number, let's say 6, 7, and this is equation number, let's say 8. Now we will discuss the conclusion of this equation. Now we will explain this equation. So here I have the conclusion, the final conclusion now. This is the ripple factor of this inductor filter. Now the ripple factor here, gamma, it is directly proportional to the load resistance. Now this implies that for small value of gamma, if gamma, we want a small value of gamma, we will use a small value of load resistance, which means high value of load current. So this shows that series inductor filter is suitable only for small value of RL or high load current, because the ripple factor is proportional to RL. If RL is smaller, then ripple factor will be smaller. So we have more DC current. There will be less variation if we use a small load resistance. So this means that this inductor filter is suitable only for small load resistance. Once there is a small load resistance, there will be a large flow of current. So small load resistance or high load current. Also number 2, the ripple factor is inversely proportional to the inductance L. Greater the inductance, smaller will be the ripple factor. So we will use, in order to get a pure DC current, we will use an inductor with large value of L. If we have large value of L, then there will be small ripple factor. So there will be small variation in the output of inductor. So this is all about inductor filter. Next we will discuss the LC filter, or we call it the choke filter. Thank you.